Welcome to All This Math. This is Professor Parker. Thank you for tuning in. Today we're going to do some work with equations of circles. All right. So what we're actually specifically going to do is, when given an equation of a circle, we're going to identify what the center is and what the radius is. And when I say identify what the center is, what I'm talking about is we're going to find out what the coordinates of the center would be if this circle that is represented by this equation was to be graphed on a coordinate plane with the y-axis and the x-axis, all right, as well as the radius. And as we remember probably from geometry, the radius is the length between the center of the circle and the edge of the circle, all right? So the first thing we want to think about is, what is the general form, or should I say the standard form, of the equation of a circle? That's the first thing we want to think about, because if we understand what that is, and then we look at this example that we're given, we know that this is not the standard form of an equation of a circle. It's not in that format. So we want to put this into that format. But before we put this into that format, what I suggest is that you write down in your notes what the standard form of an equation of a circle is. All right? And basically, it probably should remind you a little bit of, the standard form of, or the vertex form of a parabola, right? Because it deals with h and k. H and k are the variables that are used to represent the vertex of a parabola. But here, h and k are going to represent the coordinates of the center of the circle. So I'm going to just write it up here. I'm going to just say x minus h squared plus y minus k squared is equal to r squared. So x and y are the values of any points on the circle, right? H and k represent the coordinates of the center of the circle. This r represents the radius. R stands for radius, right? And in the equation, the radius is squared, all right? So this is what we're going to do. We're going to take what we have here, and we're going to try to put it into the format of the standard form of an equation. And once we do that, we'll be able to just look and just pull out the coordinates of the center of the circle, and we'll be able to pull out the value of the radius. So the first thing I want to do is, I want to put all my x terms to the left, on the left side of this equation, left side of the equal sign, and also all my y terms to the left side. And I think I wrote something wrong. Actually, yeah. This is not supposed to be 10. This is supposed to be 10y. I was wondering why I didn't have a y term, a y to the first term. All right? So what I'm going to do is I'm going to just change the order of this x squared and this negative 6x, and I'm going to rewrite it as x squared minus 6x. I'm going to bring this negative y squared over here, and when that happens, the sign changes because I'm basically transposing. When we're doing algebra, remember, anytime you move a term from one side of the equal sign to the other, the sign changes. So if this was negative on the right side, it's going to be positive on the left side. Don't ever forget that. So we got plus y squared, and then this positive 10y moves over to the left also, right? So that's going to be minus 10y, okay? Then I write my equal sign. And I want to leave a constant on the right side. I want to leave a constant on the right side. All right? Now, what I want to do is I want to put this into the form of the standard, or the standard form of an equation of a circle. So basically, I need to have a binomial that has x in it, right? And that's raised to the second power. Then I need a binomial that has y in it, that's raised to the second power. All right? Now, we're going to have to do something called completing the square. Completing the square. If you need a refresher on how to complete the square, I have a video on the All This Math page. You can scroll through the videos. I have a video that you can find where I go into great detail on how to do that method, how to complete the square as a method for solving quadratic equations. All right? If you need more instruction on it. But now I'm going to show you how to do it kind of quickly. So basically what I'm going to do is I'm going to separate I'm going to separate the x terms and the y terms, right? So I need to, and when we say complete the square, what we mean is we're completing the trinomial square, the perfect square trinomial. That's what we're completing. Right now, this is a binomial, but we want to take this and kind of expand it out into a perfect square trinomial, right? So we're going to use this little formula, which is b over 2 squared, all right? That's the formula we're going to use, b over 2 squared, all right? We're going to use it for the x's, and we're going to use it for the y's. We're going to use it for the x's, and we're going to use it for the y's, right? Now, check this out. if I do b over 2 squared for the x's, my b term is always the coefficient of my variable to the first power. So with my x's, my b term is the coefficient of my x term, right? So my coefficient of my x term is -6. So my b is -6. My b is -6. So I'm going to throw that into the formula. And I'm going to have -6 over 2 squared. And then I do the math. I do -6 divided by 2, which is -3. And then I do -3 to the second power, which is +9. So this 9 right here is going to complete the square for the x's, right? That's what it's going to do. I'm going to use that to complete the perfect trinomial square, right? So it goes from being a binomial to a trinomial. I just completed the square, just like you would complete your homework, right? Now, I got to apply this formula to the y's because I got to complete the square for the y's too. So I'm going to do b over 2 again to the second power. And my b is -10, right? So I'm going to replace the b with a -10. So now I got -10 over 2 to the second power, right? So I do -10 divided by 2, that gives me -5. Then I do -5 raised to the second power, which gives me not -25, but it gives me +25. Whenever we take a negative and we apply even number exponent to it, we always get a positive result. So that's going to give me +25. Now, 25 completes the square for the y terms. So now I'm going to write the equation over again, except now I got x squared minus 6x plus 9, right? See that? X squared minus 6x plus the 9. And now I got plus y squared minus 10y plus 25. Now, it's something I got to do to keep everything balanced, because in algebra and in mathematics in general, we want to be balanced with everything we do. We had a 97 on the right side of the equation. I can't just willy-nilly just add 9 and 25 to the left side of the equation and just think everything is cool. No, you got to keep everything balanced. So if I add 9 on the left, I got to add 9 on the right. And if I added 25 on the left, I got to add 25 on the right. Because in math, we want to be balanced. Everything got to be balanced. Just like in life, you want to have balance in your life. You want to have balance in your life. You want to have balance in your math problems. All right? So now, I can factor this and I can factor this into a form that looks like this and like this. This is called a perfect square trinomial. I know that because my constant term is a perfect square, right? And my first term is a perfect square. And if I take the square root of each of these, I get x and I get 3. If I take those two terms and I multiply them together and then I double them, I should get the middle term or the exact opposite of the middle term. And I do. The square root of x squared is x. The square root of 9 is 3. X times 3 is 3x. If I double 3x, I get 6x. That's the exact opposite of -6x. So that means that this is a perfect square trinomial. And whenever I have a perfect square trinomial, the way that you factor it is like this. You just write a binomial, put an exponent 2, take the square root of the first term, put it there, take the square root of the last term, put it there. Now, you should be wondering, what sign is going to go in between the x and the 3? Good question. You take the sign of the original middle term, which was minus. So that's that. Now that's factored. That's how you factor any perfect square trinomial. That's how you do it, right? Now, we're about to do the same thing for the y trinomial. So now I got my plus sign, and now I know this is a perfect square trinomial for the same reason that that one was, right? So I do my binomial, exponent 2, square root of y squared, bring the y down, square root of 25, bring the 5 down, this minus sign, bring that down, then I write my equal sign, then I got to do my arithmetic. 97 plus 9 plus 25. What I'm going to do is I'm going to do 97 plus 3 and get 100. 100 plus 25. Then I'm going to add the other 6 that's left over from the 9. Because remember how I took 3? It's just a little trick I use to do mental math sometimes. All right? So, 125 plus the 6 gives me 131. Now, we took this original problem, this original equation, and we put it in standard form, right? This is the standard form of the equation of this circle, all right? So now, all I got to do is say, okay, watch this. H and K is the center. R is the radius. So what's my h? My h is 3. Now here's one thing you got to be careful of. This is minus 3, so you would think it's a negative 3. But in this case, it's not. The h is not a negative 3. We're saying we're subtracting a positive 3. Because peep what the standard form of the equation says. It says x minus h, right? So that means that the h is actually just the 3. I know that might sound a little tricky, but just understand. Now here's the thing. If this was x plus 3, then that would mean, now follow me here. If this said x plus 3, then that would mean that h was actually negative 3. This is why. Because you get x plus 3 when you got a double negative. Double negative. It's kind of like this. If this h was actually negative, this would end up being minus negative h, right? So basically what you do is you just take whatever number is right. Well, basically it's like this. Under normal circumstances, you would think that this is a negative 3, that this should be a negative 3. And it is technically, right? But in the case of finding the center, the coordinates of the center of a circle, we want to basically take the opposite of this number. So if this is a negative 3, it looks like a negative 3, we want to treat it like a positive 3. So therefore, the coordinates of the center are positive 3, and the same thing with the y value, right? Positive 5, right? Now, the radius. R squared is equal to this number. R squared is equal to this number. R is not equal to this number. So we say, okay, well, if R squared is equal to 131, then how do I solve for R? I need to get rid of that exponent. So I get rid of the exponent by taking the square root of R squared. And that gives me the square root of 131. So now I got R equals the square root of 131. So now I got my center is at the point 35, and my radius is the square root of 131. If you want to be technical, we can convert that into a decimal. We get 11.45. But this is the center, and this is the radius, and this is how we figured it out. All right? So, if you feel like, I like markers like this, the little magnets. It's kind of fly, right? But anyway, if you feel like you learned something from this video, hit the like button. All right? If you haven't subscribed to the page yet, subscribe to the page. Tell some people about it. Also, turn the notifications on the YouTube, right? Turn the notifications on so whenever I drop new content, you'll be the first to know about it. All right? Because you never know when you're going to need, some tutorial or some type of video support that you can go use at your own pace to help you with your homework. All right? And, just share the video so other people can find out what we're doing in all this math in terms of offering support out here. All right? And as I always say in every video, remember that there's all this math all around you. Peace.